Welcome to qnawire.
This is the free body diagram for this problem. For part A, we know we want to use the kinetic friction coefficient because we're told that the box is moving at constant velocity, so it's not stationary. We want to find the force exerted in the diagonal here to keep it moving at constant velocity. We have a normal force pointing up, a friction force pointing to the left, the force exerted by the woman downward at an angle theta, and we have gravity pulling downward as well. And so the first thing we're going to do is the sum of the forces in the y direction. And we know this is equal to 0 since there's no acceleration in the y direction. This implies that the normal force minus mg minus f times sine theta is equal to 0. And we can solve this for the normal force. mg plus f sine theta. Now, since the friction force is the coefficient of kinetic friction times n, this is equal to mu k mg plus mu k times f times sine theta. Now we're going to do the sum of the forces in the y direction. This is also going to be equal to 0. Actually, I'm sorry, we just did the y direction. Now we're going to do it in the x direction. And if we look back here at our forces, we have the f cosine theta, and we have the f sub k, and that's all we have. And so this implies that f times cosine theta minus friction force is equal to 0. And we found the friction force before, so I'm just going to plug in that expression. So I get minus mu k mg minus mu k f sine theta is equal to 0. Solving this for capital F, which is our desired quantity, we get that big F is mu k times mg over cosine theta minus mu k sine theta. And that's the force that the woman has to apply to keep the crate moving at a constant speed. Now for part B, we can borrow the result from part A, except now the crate is not moving. We're trying to get it to move, which means that we're going to replace mu sub k with mu sub s. Since the crate is not moving, we have to use this coefficient of static friction instead of the coefficient of kinetic friction. That leads to a force of mu s mg over cosine theta minus mu s sine theta. This is just the previous expression, except I replaced mu k with mu s. Now, f goes to infinity. The force required goes to infinity when the denominator of this expression goes to 0. So when cosine theta minus mu s sine theta is equal to 0. Solving this for the coefficient of static friction gives a value of cotangent of theta, and that is the value that they're looking for, and that's the final answer.